For lesson 2, we'll be talking about solving one-step equations. And these equations specifically involve addition and subtraction. When we get to some later lessons, we'll talk about one-step equations that have multiplication and division. An equation tells us that two expressions are equal. In other words, the right side is equal to the left side of the equation. What that means is the equal sign is like the middle, and on the left side you could have something like a plus 5. On the right side maybe you have 10 plus b. In 6th grade we won't do anything that crazy. It would just be something like this. A plus 5 equals 10. So the left side equals the right side. All right, so look down here. See if you can figure out A, B, and C. So of these three, which ones are you able to find the answer for in your head? And are some harder to solve than others? So just take a minute and think about that. Okay, so for me, this first one, I could kind of guess what A is because I can figure out what I need to add to 13 to turn it into a 27. With B, this one's a little bit more complicated because it has the subtraction and they're both decimal numbers. So it's not necessarily as obvious for that one. And then for C, we have 2 multiplying the C, and then we add 1.5. That's a two-step equation. That's not actually something we would do in 6th grade. So for C, you have to visualize multiplying C by 2 and then adding 1.5 to get the 4.7, which is definitely more complicated than this one over here where we can just say, oh, well, 14 plus 13 is 27. So to solve equations, there's a process. And even when you're doing something that seems simple like A, we're going to follow the process because it's important for when we get to something like C. And if you don't ever learn the process on the easy ones or the simpler ones like A, it's going to make solving C and things that are even harder than C so much more challenging. So show your steps even if you feel like you don't have to, because we're learning the process here, not necessarily just trying to get the answer as fast as we can. To solve equations, we must undo each operation in the equation. To do so, we use the inverse operation. You can kind of think of the word inverse like the word opposite, but that word really only applies when you talk about adding and subtracting. When we get to multiplication and division, opposite is not quite the correct synonym for inverse. So the inverse of addition, or the opposite of addition, is subtraction. The inverse of subtraction, then, is addition. So when you're solving equations and you're undoing, you just perform the inverse operation. So if you see adding, you'll use subtracting. If you see subtracting, you'll use adding. When you solve an equation, the entire idea is to figure out what the variable is equal to. So if we look at number 1, we might be able to guess C plus 5 equals 12. Well, C probably has to be 7 because 7 plus 5 equals 12. But what we want to do is show the steps, prove that that's what C is equal to. So my first step is always to draw a line down through the equal sign to show the two sides, and then I look for the variable. So I see it here, it's the letter C, and I look and see what's happening to it. And what I see happening to the C is a plus 5. The entire point here is to get C all by itself. And to do that, we're going to undo or use inverse operations to get C all by itself. So if C is being added to 5, I'm going to do the opposite of that, which is subtract 5, so that I can get a 0, because a plus 5 minus a 5 is 0. Now the problem is, anytime you make one change to a math problem, you have to make a second change so that things stay equal. So when we subtracted 5 on the left side, if we want it to stay equal, we also subtract 5 on the right side. And when I say side, I'm meaning on either side of that line that I drew down through the equal sign. So on the side with the C, a plus 5 and a minus 5 makes a 0. We did that on purpose. Now it's just C on that side. On the other side of the line, it's 12 minus 5, and that's just 7. So we got what we thought we were going to get. Let's try number 2. Draw your line down through your equal sign. Look for your variable. I see x. What's happening to x is it's being added to a 10. The opposite of adding 10 would be to subtract 10. Why do we do that? Because if you add 10 and then you subtract 10, that turns into a 0. And when we're adding, 0 does nothing. So it's very helpful to make a 0. If you do something on one side, you have to do it on the other. It's that math rule of keeping things balanced. These 10s cross out because they made 0. We just have x on the left side. And on the right, we have 15 minus 10, which is 5. This does work exactly the same way if you use decimals and fractions. So draw your line down through the equal sign. Look for the variable. See what's happening to it. So what I see is it's being added to 1.4. We want the opposite of adding 1.4, which would be subtracting 1.4. Why? Because 1.4 minus 1.4 is 0. So that's going to get rid of all that stuff on the side with the b. Now, if you do it on one side, you have to do it on the other. Line it up. B on the left side and 1.0 on the right side. So it works exactly the same with decimals and fractions. Draw your line down. Look for the variable. It's y. It's being added to 1/4. So subtract 1/4 on both sides so that it stays equal. On the left side, a plus 1/4 and a minus 1/4 are exact opposites, so they make a 0. We just have y left equals whatever 6/8 minus 1/4 is. I'm going to do times 2 times 2. Remember, whatever you do to the bottom, you do to the top. 6/8 minus 2/8, which is 4/8, or 1/2. All right. And that's it for our one-step addition equations. I am going to put the answers up for the practice, and you can pause here if you'd like to check them out. And here are the answers for 5 through 8, some extra practice. Now, sometimes you get a subtraction equation. It's the exact opposite of what you do for an addition equation. Draw your line down the middle through the equal sign. Look for the variable. It's m, and it's being subtracted by 2. Do the opposite of minus 2. That would be plus 2, because a minus 2 and a plus 2 make a 0, and that's what we're trying to do. We want those 2's to go away. So now this side's just m, and we add 2 to the right side to keep things equal. M equals 9, and you probably could have guessed that, but the point is to show the steps. Number 10, draw your line down. Look for the variable. It's being subtracted by 20, so I'm going to add 20, both sides. Cross out the 20s. C equals 70. Okay, a couple of more challenging ones. Draw your line down. Look for the variable. It's k. It's being subtracted by 3.2. Do the exact opposite. Add 3.2, both sides. Draw your line across. The negative 3.2 plus the 3.2 makes a 0. So this is just k on the left side. 6.2 and 3.2 would be 9.4 is k. And lastly, with fractions, same deal. Draw your line down through the middle. Look for the variable. See what's happening to it. Do the opposite. Plus 1/3. Plus 1/3. Cross it out. Makes a 0. H equals whatever 8/9 plus 1/3 is. I'm going to make a common denominator of 9. So 8/9 plus 3/9, which is 11/9. And again, for 13 through 16, I will show the answers, but we're not going to go through them in the video. And there's the work for 13 through 16. Feel free to pause here and jot those down. And lastly here, I'll show you one of our challenge equations. These are a little bit harder because they also have combining like terms, but I'll show you one just in case you see it. So for number 19, 2k minus 5 minus k equals 10. So I'm going to group together the 2k and the minus k, and then the minus 5. So now I'll rearrange 2k minus 5 equals 10. 2k minus k means 2k minus 1k, which is just 1k or k minus 5 equals 10. You might be able to see the answer, but show your steps, draw your line down, do the opposite, so add 5. These make 0. And k is 15. All right, for the other three, if you'd like to try them, feel free, but I will not be showing them in the notes. All right, and this exit ticket question will pop up in the Ed puzzle right here.